going to start class in 3, 2, 1. Good morning!
Good morning,
Hi.
Mr. Butter.
Hi everybody, my name is Mr. Butter. Welcome to 9th grade science. Here's what we're doing today. We are learning about intro to covalent bonding. As you recall, we just learned about ionic bonding last class, which was, wait, what happens in ionic bonding? Somebody shout it out. What happens in ionic bonding?
Electron goes from atom to atom.
Yeah, an electron goes from one atom over to the other. They become charged. Why do they stick together?
Because they're charged.
We know about opposite charges, they stick together, right? We're going to now look at the stronger bond. It's called a covalent bond. It's a little bit different. It's a little more complex. But we're going to learn a little bit about how they go with your intro to covalent bonding sheet. Make sure you picked up one of these sheets before you finish watching these videos. Let's go ahead and read together. Can you have out a pencil while you read? And we'll do a little bit of underlining and stuff. Here we go. So far, we've talked about ionic bonding. Oh, look, it's like I knew what I was about to read. The process of losing or gaining electrons in order to make charged atoms. I'm just going to circle that to key my brain in. We're learning about ionic bonding. That was losing and gaining electrons to get those charged atoms. Those charged atoms are then attracted to each other by electromagnetic forces, and they combine in what are called ionic compounds because of that attraction. Okay, good. That's fine. Let's move on. In this activity, we're going to look at a different way for atoms to combine to form compounds. This new way also involves the outer shell electrons, because that's where all chemistry is happening, that outside shell electron. But this time, both atoms will share some of their electrons. Oh, snap. That's a different situation. That sharing electrons is called a covalent bond. I'm circling that, keying my brain in. There it is. Boom. This is how we learn stuff. Co, remember, means shared. Valent is talking about that outside shell of electrons. And then atoms that are bonded covalently form what are called molecules. For instance, H2O. I'm going to show you how to do this activity. I'm not going to lie, it is tricky. It's tricky. Do the best you can, especially those of you watching the video, to blast through as many of them as you can. If you have to leave a couple blank with question marks, that's fine. Bring those in, but there will be a bunch you'll be able to do. Those of you that are in class, you'll be able to get some help from me, and we'll get through all of them, probably. But here's basically how it goes, so be ready to draw along with me. In the box, we're going to draw with circles the atomic symbol for each atom that's in the compound. Tip, pro tip, pro tip. If there's any compound here that just has like a lone element, so for instance, we'll look down, do you see our NH3? You see how we got 3 H's and 1 N? Which one of those should we put in the middle when we go to draw where they're at?
N.
Yeah, the lone element should say centered. It's just going to make the drawing easier. And it's actually it's accurate to how the molecule is. You're then going to put the appropriate number of dots around the symbol to make that Lewis dot structure. Those are fun and easy. Use separate colors for each atom if you want. It makes it easier if you use separate colors for each atom's electrons if you want. And then draw a circle around each atom and all of its electrons, while also including enough from the other atom so that there are 8 electrons inside your circle. Your circle is representing its valence shell. Does that make sense? So you're going to draw a valence shell circle. You're going to grab all the original electrons from that atom, and then you'll borrow one or you'll share one with another atom to make a full 8 shell. You'll see how it goes. Except for hydrogen, how many electrons does hydrogen actually need inside its shell?
2.
Just 2. Why? You should have the same number of circles as you have atoms. So every atom needs a circle around it showing its valence shell. And then you're going to figure out how many pairs of electrons are shared. Oh, have I mentioned that these will always be shared in pairs? How are they going to be shared? In
Pairs.
Pairs. You'll never share 3 electrons. That's impossible. Can't do it. You could share 2 pairs. How many electrons would 2 pairs be?
1. 4.
4. That's okay. 2 pairs of electrons could get shared, so you get 2 and 2. That would be 4 electrons. You could even, if there's sometimes when you get 6, but that's crazy. We're not going to look at that today. You'll always share in pairs of electrons. That's the number of bonds. Each pair of electrons that's shared is a bond. And so that'll tell you how many bonds there are. Let's look at the covalent bond between 2 fluorine atoms. We'll start by drawing our fluorine atoms. I'm going to do one in black. How many electrons does it have in its outside shell?
2. Oh. 7.
Yeah. There's 7 electrons in fluorine's outside shell. Can you take a look at where the direction I'm drawing the lone one? I'm sort of sorry. I'm so sorry. On the video, I'm going to be sick too. This will be forever recorded. We're going to pretend that we can like rotate the atoms to face each other, and so we'll put the lone electron facing the other atom. I'm going to draw the other atom, the other fluorine in blue, just so we can tell them apart. And again, I'm going to draw the 7 valence electrons, and I'll rotate so that the lones are facing each other. I know that that's where they're going to that's where the bond's going to be. Okay, you got it, you got it, you got it, you got it. Now we're going to draw the circle of the valence shell for the fluorines, okay? So we'll start with this fluorine, and I'm going to circle up its valence shell. I'm going to make sure to scoop up. How many electrons do I need in its outside valence shell? How many electrons? 8 is your magic number, right? I'm going to watch me scoop all 8. Here we go. So I'm going to start by scooping up these 2. I got 1, 2 in there. I got 3, 4. I got 5, 6. I got this original 7, right? And then could I borrow this one into the valence shell too? Yeah. Oh yeah. So let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Nice. That fluorine is happy. It's sort of borrowing this electron from this fluorine. It's made itself happy. I'm going to switch colors back to my original black for the original fluorine atom. I need a valence shell circle for all the atoms in this compound. So here we go. Here's the valence. Are you ready? Are you catching up? Here we go. I'm going to catch 8 electrons for this fluorine. Here we go. 1, 2, 3, 4. So I got 1, 2, 3, 4, 5, 6, 7. And then where's my 8th one going to come from? Right there. Okay. Let's double check. Yeah, circles intersecting circles. It's going to get complex. Let's double check. Do we have 8 electrons in this fluorine atom's shell? We got 1, 2, 3, 4, 5, 6, 7. The original 7 plus it's borrowing 1 from that fluorine. So how many pairs are shared between these right now?
2.
Pairs.
1.
2 electrons makes 1 pair. Yeah.
But
Yeah. Question. Hit it.
won't they have the same amount of electrons though? Because if you're borrowing what you need, but in return you still have the same thing.
Isn't that fascinating? Neither of them have given up an electron, but what we've
So it's
done is they've
neutral.
sidled up. Oh yeah, it ends up being neutral. The charge is still neutral. Because we had 7 protons, 7 electrons for that fluorine. Still 7 protons, 7 electrons. They're both neutral, but they've made their outside shell happy by getting so close to each other that these 2 electrons live in the outside shell of both. Is this making sense? And so their shells actually overlap and are connected together. These electrons, let's talk about what the electrons are attracted to maybe. This electron here is it's a negative charge, right?
Yeah.
Why doesn't it just fly off into space?
Because it's going.
What's
it's
in the nucleus down here that's attracting it?
magnetic.
Yeah, what's the charge on the protons down there?
Positive.
Positive, right? So this electron is attracted to those positive protons. But now also, it's now also attracted to the positive protons in this nucleus. And it's become part of that shell. And the same thing here, this electron is attracted now to that nucleus and that nucleus. And so there's these forces that are keeping them hooked together. And they're our shells are full, and we are stuck now sharing this little bond. And that is your bond, your one paired share of electrons. We're going to keep moving. Maybe it'll continue to make